Hi everybody. In the last video, last couple videos, we've been looking at nonlinearity functional forms in regression equations. So, a couple videos ago, we looked at if we want to see a relationship that exhibits diminishing marginal returns to scale, we'll do something like y is equal to beta 0 plus beta 1x minus beta 2x squared. So we're adding the x squared term in there. If we want increasing returns to scale, we do a log function, log of y equals beta 0 plus beta 1x. These would be estimates. And so just depending on what we're modeling and whether they exhibit these types of behaviors, then we can include those appropriate terms in the model, x squared or log y. This is called this one here is called log level because we have log here and we have a level in x. We're going to end this series with log, where we're going to have a log of y, and that's going to be related to a log of x. But we still have it's a nonlinear functional form in x, but we still have a linear regression because we're linear in our beta parameters. All right, and so as before, we're going to do this by way of example. And the example we're going to use is CEO salary is a function of their firm's sales. And so we would think that if sales increase, salary will increase. And so first of all, let me just show you what we would have for a level model. That would be something simply like salary is equal to beta 0 plus beta 1 times sales plus our error term. And the beta 1 is interpreted as we know, I won't write it down. Beta 1 means that a 1 unit, so let's say if these are, let's just keep things simple. If sales is measured in dollars and salary is measured in dollars, a $1 increase in sales is associated with a beta $1 increase in CEO salary. Okay, but especially for numbers that are going to be super big and you're going to have huge sales numbers, maybe in millions or billions, and maybe even the same for hundreds of thousands or millions in salaries, it might be nicer to interpret these as elasticities or as percentages. And we can do that with a log model. And so there we're going to use the natural log of salary as a function of the natural log of sales. And so when we do that, here, beta 1 is the elasticity of salary with respect to sales. Okay, and so the way that we can, well, we'll look at the interpretation, but let's do the interpretation with an example. So if we get some data and estimate that, which we'll do in Python. So our predicted salary is equal to beta 0, and suppose beta 0 equals 4.82 plus 0.257 times the log of sales. So beta 0, beta 1. The interpretation of this is it's an elasticity. So a 1% increase in sales is associated with a 0.257% increase in salary. And I do want to just note that this is 0.257%, not 25.7. So it's already in percentage terms when we do a log-log model. So this is 0.25%, not 25%. Okay, and then again at the end, always remember ceteris paribus. Everything else held constant. Okay, so this is maybe the simplest. Left the easiest for last. But yeah, we do a log-log model. We can interpret this as a constant elasticity, and it gives us a nice, easy way to especially when we're dealing with maybe large numbers and salaries and sales, or if you're actually looking specifically for elasticities, price elasticity of demand, of income, cross-price elasticities, you're going to use these log-log models. Okay, so just to summarize, I want to include all of the different models here related to logs. But actually we'll start first with level regression. And so I'm going to write down what we use for the dependent variable, what we use for the independent variable, and the interpretation. So dependent variable for level is just straight up y. For independent variable, it's straight up x. I'll do the interpretations last. Log level is log of y. These are all natural logs, and just the normal level of x. Log, which we just covered in this video, is the log of both. Log of y, log of x. And the one that we didn't cover, just because it's less common, is level log. And so we would have the level of y and log of x. And that too, it's going to have a percentage interpretation. It's just not so common, and this one is more useful there. This one will give us that exponential relationship, and then level is as normal. And so the interpretation, just to summarize some more, the change in y is equal to beta 1 times the change in x for level. For log level, we have a percentage change in y, and we're going to add 100 there to make it into a percentage, beta 1 times the change in x. And then the log is the percentage change in y with respect to a percentage, beta 1 percentage change in x. And I'll just include it here, but for the last one, it's the level change in y with respect to a beta 1 percentage change in x. Okay, and so that gives us a summary of what we've talked about. So the other last one, although technically it's a level, we did talk about quadratic, and I guess we interpreted it, so we have a y, we have an x, and we also have an x squared, and yeah, let me go ahead and add it to our summary. The interpretation of that is going to be the percentage, or the change in y with respect to x is going to be equal to beta 1 plus 2 beta 2x. And so the beta 1 goes with the x, the beta 2 goes with the x squared. Okay, and so that's, slightly different, but it's part of our nonlinear functions summary. And again, the quadratic is if we want a diminishing marginal returns. Log level is if we want increasing marginal returns. Okay, and so yeah, this would hopefully be a nice summary that you can go back and reference when you need to. Let me make sure it fits on the screen. There. Yeah. And that's gonna do it for us for now in terms of nonlinear functional forms in the use of linear regression. So in the next several videos, we're going to be putting these into practice. Throughout these videos, I've shown some estimated betas and regression coefficients. We're actually going to go through and build out those regression models in Python to show you how this stuff works in practice. Okay, so hopefully the theoretical background will give you some insight into why we're actually doing it. But yeah, in the next videos, we're actually going to do it. So thank you for watching, and I will see you in the next video.